Hello everyone, here we have another brilliant question. A particle is released on a vertical, smooth, semicircular track. This track is vertical, it is smooth means there is no friction involved and it is in vertical plane. Whenever the word vertical and horizontal are used, we have to take the gravitational force into account in the free body diagram. So particle is released from rest at the position x. It's mentioned in the question B. Now this particle goes along the circular path and reaches at position y. Question says at position y the normal force on the particle becomes 0. Mg would be yet acting on the particle, the gravitational pull. We show that mg like this. If you drop a perpendicular here, you can complete a triangle. This angle is phi, this angle is 90 degrees. So the angle here would be 90 degree minus phi, and this angle would be phi. So mg will have two components, the rectangular components, mg cos phi and the mg sin phi. This mg sin phi is basically the centripetal force because the particle is moving on the circular arc. So one thing we can write for the solution that mg sin phi is the centripetal force. At the location y there is no normal force. Mg sin phi is the centripetal force. Mg cos phi is the tangential force which is responsible for the gain in the speed of this particle, because the velocity vector of the particle at this moment would be in this direction only, and this tangential force will keep on increasing this speed v as the particle comes down. Now the formula for centripetal force we already know, it is mv square by r. We consider the speed here to be v and the radius is capital R. Here in the left hand side we have mg sin phi. We can cancel out that m. Okay. So we are left with g sin phi is equal to v square by r. Now we need to obtain the v square for calculating the things further. To obtain the v square, let us focus on the diagram once again. In this diagram, if we watch carefully, the particle came down by some distance from here, the position x to position y. The particle came down by a distance h. When particle is coming down by a distance h, it is losing its gravitational potential energy and gaining the kinetic energy. So let us find that h. For finding that h, we do some construction here. From point x, we draw a perpendicular like this. This radius is also r. This angle is theta. Anyone can tell this length. This length would be equal to r cos theta. Agree with it? Similarly, if you draw a perpendicular from here, like this, and we know this length is r, this angle is phi, this distance here to here will be r cos phi, and this distance would be r sin phi. I am talking of this green distance, or you can call this distance. This would be r sin phi. So mentioning that distance, green distance here as r sin phi. What would be the h then? Well, the h will be r cos theta minus r sin phi. Let me write it somewhere. The h would be r cos theta minus r sin phi. Agree? Now on the next page, we'll write one thing, that loss in gravitational potential energy, which is mgh, should be equal to the gain in the kinetic energy, which is half mv square. So switching to the next page, when particle came down, it loses the gravitational potential energy. the loss in gravitational potential energy is equal to the gain in kinetic energy. Now, the loss in the gravitational potential energy is mgh, and the gain in kinetic energy is half mv square. You can cancel out that m here. So we get the v square is equal to 2gh. And the value of h is also known to us. H was present at the previous page, r cos theta minus r sin phi. So H is r cos theta minus r sin phi. Okay, put up the data here. So V square comes out to be 2gr cos theta minus sin phi. Because from this computation of H, you could have taken r common, and then you are left with cos theta minus sin phi. Okay. This value of h we have replaced here, so we got the final value for v square. Now taking the computation further, on this page you would require the value of v square by r. So v square by r is also visible. V square by r is equal to 2g cos theta minus sin phi. Keep in mind, v square by r is equal to 2g cos theta minus sin phi. We have to submit that value of v square by r here. Now, g sin phi is equal to v square by r. The value of v square by r is already available. It is 2g bracket cos theta minus sin phi. So, putting up the data for v square by r, it is 2g bracket cos theta minus sin phi. Agree? Okay. Now, simplify this expression further. I'm just making a little bit of the space, as will require some space for the calculation. Okay. So the g and g is getting cancelled out. Here we have sin phi. Here we have 2 cos theta minus 2 sin phi. This 2 sin phi, I am shifting to the left hand side. So 2 sin phi plus sin phi will make here 3 sin phi is equal to 2 cos theta. Do we have any option which says 3 sin phi is equal to 2 cos theta? I think this is the third option. The 3 can be brought here. So we have 3 sin phi is equal to 2 cos theta. That is the correct answer. I hope you enjoyed the solution. If you have yet any other doubt, please post that in comment box. If you enjoyed this video, please like it, share it with your friends, and kindly subscribe to this channel. Stay awesome and see you again.